Hello everyone, welcome to Ghana ICT Club Code with Kwaku. If you are new here, please consider subscribing to this channel. And if you've already subscribed, thanks for showing up. This episode of Code with Kwaku, we are continuing our SQL for data analysis class. And this is the week 2 of the class. So in the week 2, we will talk about data types, constraints, and tables. And week 2 is divided into 2 parts. We have the week 2A and week 2B. Week 2A will talk about data types and constraints, and week 2B will talk about how to create tables, alter tables, and drop or delete tables. Okay, so SQL data types. The data type of a column defines what value the column can hold. So for example, if you are filling a form online, for instance, in creating a Facebook page, a form may require that you input your email or contact details. So the field that requires your email will have a data type set to email. That means it should take only emails as a value, or a form or a field in a form can be set to take only date values. So in SQL there are a lot of data types that we can talk about, but the basic ones are integers, which take numbers, then characters or money. You can set a field to take money as a value, date or time as a value, binary, float numbers, and so on. So as we move on, we will see the different data types. Then the data type is a guideline for SQL to understand what type of data is expected inside of each column. So as I said, if a field in a column requires an email, you can't type your phone number there. So basically, data types help SQL to know the particular data or value that is expected of a user whilst filling the form. And the data types are grouped into strings, numeric, date and time, boolean, and so on. So string simply refers to text, numeric refers to numbers, date and time will refer to the normal date and time that we know. We have float. There are a lot of them, but we only talk about the common ones. Okay, so this table gives the various data types and its description. So you can just read through. We have character into bracket size. So character into bracket size is where you will specify the number of characters that you want that field to hold. So for instance, you can set a field to hold up to 10 or 50 characters. So when a user enters data which is more than 50 characters, depending on how much size you set, the system will automatically truncate the text to only 50 characters. Then we have variable characters, which takes numbers, letters, then special characters, and it can take up to 65,535 characters. Then we have binary, a lot of them, tiny blob. So you can just take your time to read through and read the description to understand. Then we have the numeric data types. So we can also have bits, tiny int, bool, boolean, small int. Int simply means integer. Integer too, you can set the number of size that you want. Maybe you want up to only 4 numbers. You can set the field to take only 4 numbers. And when a user enters more than 4 numbers, the field will truncate or remove the excess numbers and leave only 4 out of it. You can also have float, then you can give the size and the number of decimal places. So float takes 2 arguments in its parentheses. So you can the float size and the number of decimals after the floating. If I want 2 decimal places, I can just give 2 so that the user can only enter 2 decimal places after the whole number. We have double decimals, so you can just read through the descriptions to understand. Then we have date and time. So a field can only allow you to enter only date, or date and time, or just time stamp, or just time, or just the year or day or month of the period. So timestamp will give a full detail of time, including the time format, the date, then the hours, minutes, and so forth. So as I said, if you read through the description, you get to understand the various data types. So as a developer, you should be familiar with the data types so that you can set your fields to specific data types, and this will help guide your system or to provide filtering for your system so that users can't just put in any data which is not required. Right. So after data types, there is this important thing that we need to look at in SQL database management or in SQL. We have constraints. So in creating a database, there are certain rules that you should be guided with when creating tables. As we spoke about in our first lesson, database is made up of objects, and these objects include the database name, the tables, and the table has fields, columns, rows. So constraints help us to set rules for the table. So constraints are used to limit the type of data that can go into a table. This ensures accuracy and reliability of the data in the table. So constraint helps to ensure accuracy and reliability of your data. So if there is any violation between the constraints and the data action, the action is aborted. So for instance, if I set, we'll talk about it, a primary key and a foreign key which links tables together, when you can decide that when you delete a record from the child table, the system should abort it because there has been a link or using a constraint, or there has been a foreign key constraint in the child table. So we will talk about them as we move on. So constraints can be column level or table level. So column level constraints apply to a column in a table. Then table level constraints apply to the whole table. So the following constraints are commonly used in SQL. So the first one is not null. Not null simply means the field shouldn't take an empty value. So until the user provides a value, the system will not allow the user to save the records or move to the next field. So if I'm designing a form that will take a user's name, contact number, and maybe email, I can set all the fields to be not null. That means it shouldn't be empty. So until the user fills up all details in the form cannot be submitted. So that is how not null works. Then we have unique. Yes, unique is very important in database. And example is that if you create a form that will take student records or users records of users. You can set a unique field for emails or contact numbers so that one person cannot use another person's email once it has already been entered into the system. So let's take, for instance, person A fills his details and his or her email address is maybe test@email.com, and person B also fills his details and provide the same test@email.com. The system will reject it and prompt the user based on the design of the form that email has already been used, or that username has already been used, because the field was made to be unique. Yes. So this makes your data accurate. Right. So it's very simple. And automatically, primary key constraints has unique values. We will talk about primary key so you understand. So to create a primary key, you only need the syntax below. If you don't understand, don't worry. We will talk about this syntax as we start creating tables. So you just look at it. Don't worry. Then we have primary key constraints. A primary key mostly sets rows to be unique, or it uniquely identify records in a table. So by default, primary keys are unique and cannot have null values. That means it cannot have empty values. So let's say I'm creating a list of 5 users. Then I give the person an ID or a primary key of 1. Then automatically the next person should have an ID of 2. I can't repeat 1 for the second person because primary keys identify records in tables uniquely. So that is how primary key works. So and a table can have only one primary key, but multiple columns can have but this primary key can consist of single or multiple fields. Okay, so the syntax below or the statement below is what we use to create primary keys. Okay, then okay, so let's talk about foreign key. So foreign key is a key used to link two tables together, and a foreign key is a primary key in another table. But when it is linked to it is linked on a different table, it becomes a foreign key. Don't get confused. When we start practicing, you understand. So for instance, we can have two tables, students and maybe departments. Students may have a student ID, department may have a department ID. But at the end of the day, if we want to link students table to department ID, then we need to create a student ID in as foreign key in department ID, so that based on that foreign key we can pull records of students in a particular department from the students table. It's confusing, but when we start practicing, you understand. So the table containing the foreign key is called the child table, right? And the table containing the candidate key is the primary key is the parent table. So this is just a demo of how primary keys and foreign keys work. So let's take a look at the customers table. You see that the customers table has a customer ID as a primary key here. But when we come to the others table, it also has a customer ID as a foreign key. So based on the value 1 and the customer ID, we can say that the person with ID number 1, which is Kwaku Dapa, placed an order or placed this order 1 in orders table. So basically Foreign keys help to create links between two tables. Yes. Right, so notice that the customer column in the orders table points to the customers column in the customers table, as I said earlier on. So the customer ID column in the customers table is the primary key and it's acting as a foreign key in orders table, and as I said earlier on. So the foreign key constraint is used to prevent actions that would destroy links between tables. So for instance, if you create a foreign key and you insert records, you can't just delete the records from the child table, because once it's linked to the parents table, you need to delete from the parents table because before it can take effect in the primary key. Or there are other constraints that you can set, either on delete, cascade, or which we will talk about later on. Right, so this syntax is how we create foreign keys. So after creating your, so this is a departments table, we have department ID, then we bring student ID as a foreign key. Then, so foreign key into bracket student ID references a table called students, and the field or the field that has the students or where we are referencing from is the student ID. So this student ID in the departments table, which is this student ID, is referencing a table called students, and the field where we are referencing from is the student ID field. When we start practicing, you understand, so don't get confused. Then we have auto increment. Auto increment simply means that when I'm creating records and I give the first record an ID of 1, the next record should increment by 1 or should increment automatically to 2. I don't need to repeat 1, 2, 3. The system will automatically increase the numbers for me. So this is also how we create auto increment. So books ID is an integer or has an integer as a data type, then has a constraint of auto increment. So the first record will be 1, second record will automatically be 2, and so on. As we start to practice, you understand. So this brings us to the end of week 2. Okay, so see you in the next lecture. Thanks for watching, and please do well to subscribe to this channel. Bye.